Before we even look at sprinklers or pipes, we've got to start at the beginning, the water source. If there's a problem here, it can impact the performance of the entire system. I'm Dr. Denise DeBusk, and in this section, we'll talk about how to review the water source and what warning signs to look for before heading further down the line. Whether you're dealing with a pump or a municipal meter, catching issues early can save a lot of time and troubleshooting later. When filling out the water source section of the irrigation service checklist, just remember it's not one size fits all. If the system has a meter and a backflow, you'll focus on the first 4 lines. If it's a pump system, skip those and use the bottom 3. Reclaimed water systems will use the 5th line, and possibly others depending on the setup. Only complete the parts that apply to your specific system. The goal is to tie the checklist to what you actually see on site, so it's fast, accurate, and useful. When dealing with surface water sources like lakes, ponds, or canals, our goal is to make sure they're providing clean, consistent water without damaging the system. We look at water quality, how much water is available, and how well the pump and its parts are working. You don't always check everything on every visit. Some things like pressure readings might be saved for spring startup or a deeper system check, but if something looks off, you'll want to dig deeper. Surface water might look clean, but hidden problems can mess up your system. Silt and clay from runoff can build up inside valves and heads. Iron and calcium can stain hardscape and clog nozzles. You've got to watch for algae, floating plants, and sludge. If plants or muck clog the pump intake, pressure drops and sprinklers underperform. Sludge on the lake bottom is fine until the suction line gets too close or a storm stirs it up. That's why keeping the intake at the right depth matters. When you're out in the field, your eyes are your best tool. If sprinklers look weak or aren't reaching head to head, the system may be struggling due to clogging or low suction. Pop ahead and check the screen or check the main filter if there is one. Also, look at the water itself. Do you see floating algae or shoreline plants creeping toward the suction line? Those can easily choke off water flow. And keep an eye out for erosion. Washed out edges can dump silt and sludge into the water and become a recurring issue if not addressed. Water availability is pretty straightforward. It just needs to be high enough for the pump to do its job. But since we don't visit every day, it's important to check if the level looks different than before. Look at the suction pipe. If a lot of it is showing and there's a stain higher up, that tells you the lake was higher recently. Shoreline marks, dock stains, or exposed roots can also clue you in. If the system seems to be working now, but there are dry spots in the landscape, it might not have been running when the water was lower. And don't be afraid to ask the property owner. They might have noticed the pond dipping below normal. When checking the pump and its parts, it's mostly about giving everything a good visual inspection. Look for any cracks, leaks, or broken fittings around the pump, pressure tank, valves, and filter. Make sure wires aren't exposed or hanging loose around the pump's start relay or electrical boxes. It's not only a performance issue, it's a safety one. You also want to look for drips at pipe joints and fittings or water pooling nearby. These could be signs of loose fittings or potential breaks. Once you've checked the pump's condition, you also want to make sure it's actually running. Turn on each zone at the controller and look for water coming out of the correct sprinklers. If nothing sprays or if the wrong ones are going, it could be a pump issue. Head to the pump and listen for it. If it's not on, check simple fixes first. The GFCI might be tripped or the breaker might be off. These are easy things to reset, and knowing them can save you a service call. Let's talk about how to measure discharge pump pressure at the pump, something you'll usually do during spring startup. If the pump doesn't have a built-in gauge, you'll likely use a hose bib nearby. Start by opening it for about 5 seconds to flush out any debris. Just make sure the water doesn't spray toward the motor or any electrical components. Then attach your pressure gauge to a special adapter made from 2 common fittings. Open the hose bib again, wait for the flow to stabilize, and record the highest pressure, even if the needle's bouncing a little. Then just close the valve and remove your gauge. It's a simple, reliable way to check pressure. Now, if you're using a threaded T instead of a hose bib, here's what to do. First, turn the pump off and remove the threaded plug from the T. Attach your pressure gauge directly into the opening. You may need an adapter depending on the size. Turn the pump back on, wait a few seconds, and watch that needle again. Record the highest pressure you see. Then shut the pump off, remove the gauge, and reseal the plug using Teflon tape or thread sealant. Once you screw it back in, turn the pump on again and make sure there's no leak. It's a little more work than the hose bib method, but just as accurate. On the screen is an example of the type of form you could use to record the water source pressure reading. When you're checking a system that pulls water from underground, like a well, there are a few key differences to keep in mind. First, the water itself isn't visible, so we can't observe the quality or the availability like we would with a pond or lake. You won't see algae or sludge, and you can't tell if the water levels dropped unless the system stops performing well. With submersible pumps, most of the system is hidden underground, so you're looking for indirect clues, like sprinkler zones not coming on, or wet soil near the wellhead after a run. If it's a jet pump on a well, like most shallow well setups in Florida, the inspection is similar to surface water pumps since the components are above ground. The bottom line, you're relying a lot more on system performance and signs like leaks, wet areas, and sprinkler behavior rather than what you can physically see or hear at the pump. When a system runs off potable water, we usually have a meter and a backflow prevention device, both installed based on local codes and utility requirements. The meter is our best tool to confirm water availability and potentially uncover leaks. Before you check it, make sure the system's not actively running. Then look for the leak detection dial. On analog meters, it might be a tiny triangle or a gear. Digital ones show low flow as changing digits. If water is moving through the meter when nothing should be on, you're likely dealing with a leak in the irrigation system or even the building if it's a shared meter. You can note the meter reading on a form like this. Backflow devices are non-negotiable on public water sources in Florida. Every system will have one, so make it a part of your routine. What are we looking for? Start with the obvious, cracks, damage, or leaking pipes. Then look underneath the device. If you see algae growth, soggy mulch, or erosion, the unit may be dumping water unexpectedly. These visual clues are easy to overlook, but can tell you a lot about performance. Just like with meters, always document your observations clearly, especially if the device needs maintenance or replacement. When we talk about preventative maintenance, checking the static pressure at the backflow device is one of those simple steps that can give us useful insight, especially during the spring startup. Florida-approved backflow devices will have test cocks. Those are your connection points. Now, if a plumber installed it, there might be specialty fittings in place, so you'll need an adapter to fit your 1/4-inch pressure gauge. Here's the quick how-to. Make sure the water meter is on. Connect your pressure gauge to the inlet side test cock. Use a flathead screwdriver to open it a 1/4 turn. Take your reading, then close it and remove the gauge. Don't forget, log your reading and any observations per your company's reporting process. It only takes a few minutes but tells you a lot about system readiness. Let's talk about reclaimed water sources. These are popping up more and more in Florida, especially in newer developments. Now here's the thing, reclaimed water might not have a meter or a backflow device. It really depends on the water utility. But what's unique about reclaimed water is availability. It can be off without any warning. This happens when the utility just doesn't have any more reclaimed water at the plant. So if the system is set to run on a day when water isn't available, the sprinklers won't run, and you might not even know it unless you spot the signs, like turf that's showing drought stress. Also, keep in mind, reclaimed systems usually don't run during the day, so you've got to plan your service times around those nighttime irrigation windows. If there's a meter, check it like you would a potable one. It's often in a lavender or purple box. If there's no meter, there's typically a shutoff valve near the street. And if there's a backflow, inspect it using the same steps as we covered for potable systems. Always document what you find and adjust your service schedule to match the quirks of reclaimed water systems. When reviewing the mainline filter at the water source, start by checking for visibility. If the filter has a clear case, you might be able to see debris build up right away. Sometimes there's a mesh sock covering it. You'll need to slide that off to take a look. If the case isn't clear, you'll have to open it up. Be sure to close the valves before and after the filter. Use the right wrench to loosen the housing and check the screen or disc for debris. Depending on the contract, you may need to clean it right then or swap it out with a fresh screen. Some filters have ports to hook up pressure gauges before and after. If there's a 5 to 8 psi pressure drop, that's your signal the filter needs cleaning. As always, record your findings using the company's process and be thorough. Mainline filters are easy to miss, but can make a big difference in system performance. When you're completing the checklist for the water source section, it's important to be clear and consistent. Start by using the number column to indicate the number of components that need attention. If everything's working fine, or if you fix the issue during your visit, mark it in the checkmark column. For anything not on the system, write NA. That helps avoid confusion about whether something was skipped. Let's walk through example 1 together. In this example, we're looking at a pump with a mainline filter that needed to be cleaned. The water source pressure, pump, and GFCI were in good condition, so they were marked OK. The filter needed cleaning, so the tech wrote a 1 in the number column. But since it was cleaned during that visit, they also added a check mark in the check column. The clogged suction line screen wasn't checked at all, so it got a 0. For all the components that weren't part of this particular system, like the meter or backflow, they marked them as NA. This kind of documentation not only protects you, but also helps with continuity if someone else is handling the next visit. Let's go through example 2, which shows a meter with a leak and a backflow device without a filter. Here's what was noted. The water source pressure and the backflow device were working correctly, so they were marked as OK. The meter's leak indicator was spinning, which means water is flowing even when it shouldn't be. That got a yes in the checklist. Since the tech didn't diagnose or fix the issue during the visit, there's no check mark next to it, and a follow-up service call will be needed. There was no filter on the system, so that row was marked NA. The key takeaway here is that even if something wasn't resolved on site, we still document it clearly so we can follow up and the customer stays informed. Every company has their own process, but consistency and transparency are what really matter. Let's wrap it up with some key takeaways. Water sources can look very different. Surface water, subsurface wells, potable city water, or reclaimed water, and each one has its own setup. You need to know what you're dealing with: pumps, filters, meters, backflow devices, whatever components are in play. As you review a water source, you're focusing on 3 main things: availability, condition, and performance. Always use the right tools to take pressure readings, detect leaks, and inspect equipment. And finally, make sure you document everything clearly, whether that's on a service checklist or in your company's preferred format. Good records mean easier troubleshooting later and a more professional experience for the customer.